So let's talk about the rest of our story problems here. Unit 2, Section 7, solving word problems. These are going to be perimeter problems. Perimeter of a rectangle, perimeter of a triangle, whatever. And in these perimeter problems, we're still going to use SQ, RQ, CQ. The length of a rectangle is 100 inches more than the width. If the perimeter of the rectangle is 1320, find the dimensions. So the length of the rectangle is 100 more than the width. So now perimeter of the rectangle is 1320. Find the dimensions. Well, what's it asking us to find? It says to find the dimensions. What does it mean by the dimensions? We're going to find the width and the length of this rectangle based on the information that's given. Now, we're also going to use those same 4 steps that we were talking about last time, and that is A, define the variable. We are going to pick a letter of the alphabet and you're going to tell me what it stands for. Now I'm going to show you a trick that my algebra teacher taught me not that long ago in defining the variable. Now, with consecutive integer problems that we were working on earlier, it was when you define the variable, it was always let x equal the first integer. But with other story problems, you have to be more specific. It's not just going to be the first integer anymore. We have to be specific here on what we're defining the variable as. And since our 2 unknowns are the width and the length, we're going to define our variable to one of those 2 things. Now, here's the trick Jim Myers taught me just a little bit of a while ago, and that is when defining the variable, always choose the second unknown mentioned. Here's the length, here's the width. Which one is mentioned second? Well, the width is. So that is what I'm going to go with when I define the variable. And I'm just going to say, since width starts with W, I'm going to use the variable W. I'm going to say let W equal the width. So here's the verbal phrase for the word width. Here's my algebraic term for the word width. Now I need something for the length. Here's my verbal phrase for the word length. That's the verbal. Now I need something for math that I can use for math, and I cannot use the letter L. Once we've picked W, can't pick any other variables. We have to stay with W. But what does it say about the length? It says the length of the rectangle is what? Well, 100 inches more than the width. Now remember what A1 was in my lecture before, was that if we're defining the variable, we also have to write an algebraic expression for the other unknowns. So I need an algebraic expression for the length. Well, what does it say about the length? It says the length is 100 inches more than the width. So I'm going to take this verbal expression and I have to write an algebraic expression. Well, what is the width going to be? It's going to be W, right? Well, how would I write 100 inches more than that? Well, how about W plus 100? So here's my algebraic expression for the verbal expression, the word length. Well, now, since I'm talking about perimeter of a rectangle, we had better use the formula for perimeter of a rectangle. And for right now, here's what I want you to do. Let's take 2 times the length and write the word length out for me and put it in parentheses, plus 2 times the width, put width in parentheses, equals P. There's the formula I want to use for this problem. Now here's the verbal phrase for that's the word length. What's the math thing I'm going to use? How about W plus 100? So we're going to put that in for the word length. Now everything else stays the same, so I'm going to have 2, and then the quantity W plus 100 plus 2. Now again, here's the word for length. What's the math symbol I'm going to be using for the word width? I'm going to be using W is equal to 1320, because the perimeter is 1,320. So here's the equation. So all right, so I've defined the variable, I've written an equation. Now I need to solve it. So I'm going to use the distributive property. 2 times W is 2W, 2 times 100 is 200, plus 2 times W, which is 2W, is equal to 1320. 2W plus 2W is 4W, plus 200 equals 1320. Subtracting the 200 from both sides, you get 4W is equal to 1120. And when you divide both sides by 4, you get W is equal to what? Your calculator, 1120 divided by 4, right, 280. So what does that mean? Well, it means that since I said from the very beginning that W stood for the width of this rectangle must be 280. So how am I going to find the length now? Well, it's 100 more than the width, so I'm going to take W plus 100 is equal to 380. So the length must be 380. Now, we've got to also check our work. Does this give us a perimeter? Do these two dimensions give us a perimeter of 1320? Well, if I were to add these two numbers together, that's 660. Now, remember, in order to get the perimeter, though, I have to double that. It does come out to 1320, so it does check out. In number 5, the perimeter of a rectangle is 222. If the length is 3 less than twice the width, find the dimensions of the rectangle. The perimeter of a rectangle is 222. The length is 3 less than twice the width. Again, we are finding the dimensions, which means we're finding the length. I have to have the length and the width. Which ones mentioned second? The width. So let W equal the width. So now I need an algebraic expression for the length. What does it say about the length? The length is, now how am I going to write 3 less than twice the width? 3 less than twice the width. Well, the 3 less than, that tells you that something's going to be minus 3. Well, what's the width? Well, it's W. What's twice the width? It's 2W. What's 3 less than that? 2W minus 3. So there's your algebraic expression for the other unknown. Our two unknowns, width and length. The second one mentioned is width. The algebraic expression for the length then would be 2W minus 3. Now let's go back and use the same formula that we had for perimeter of a rectangle. Perimeter of a rectangle, 2 times the length. I would write it out in words for right now, plus 2 times the width equals P. And now I'm going to put 2W. Now look at what I am writing here. The 2W minus 3 goes in the parentheses. The 2W minus 3 goes in parentheses. What's on the outside of it? Right, there's a 2 there. So it's 2 times the parentheses 2W minus 3 plus 2. What am I calling the width? It's W equals 222. Solve the equation. Use the distributive property. 2 times 2W is 4W, minus 2 times 3 is 6, plus 2W is equal to 222. 4W plus 2W, 6W, minus 6 equals 222. Adding 6 to both sides, 6W is equal to 228. And when you divide both sides by 6, you get the width being 38. So if the width is 38, what's the length? Well, we're going to come back over here and go and find the length. We're going to take 2 times 38, which is what? 76. 76 minus 3 is 73. So our length is 73. It's always a good idea to make sure that that's going to work out. So let's add those two dimensions together and then double it to see if we get 222. 8 and 3 are 11. 111 times 2. 222. It does check out. We have our two dimensions. Number 6, the length of a rectangle is 5 feet more than twice the width. The perimeter is 214. What are the dimensions? Now, if you want to, you can go ahead and pause the video and see if you can figure this one out on your own. If not, we will keep going. So again, we're finding the dimensions of the rectangle. The dimensions as described here are the length and the width. Which one's mentioned second? Width. So I'm going to say let W equal the width. Always the second one mentioned. Now I have a verbal phrase here for width. It's the word width. I have the word length for my other unknown. Now I need to write an algebraic expression for the word length. The length is, now I'm going to have to take this, 5 feet more than twice the width. 5 feet more than twice the width. Well, what's twice the width? That would be written as 2W. What's 5 more than that? Plus 5. Again, we're going to be using the formula, and make sure you write down the formula because I've seen too often where we don't write down the formula first, and that's where you get jammed up. So we're going to go with 2 times the length plus 2 times the width equals P. And we're going to take this 2W plus 5 and put it here. So the parentheses 2W plus 5. What's on the outside of it? That 2. Then we're going to do plus 2, and then I have the parentheses. What are we using for the width? W is equal to, and what's our perimeter? 214. Using the distributive property, I'm going to have 4W plus 10 plus 2W is equal to 214. 6W plus 10, 214. Subtracting the 10 from both sides, 6W is equal to 204. Dividing both sides by 6, we get the width is what? Plug it into your calculators and you'll get 34. So if the width is 34, what's the length? Well, we take 34 and plug it back into here. 34 times 2, 68. 68 plus 5, 73. Does that equate to a perimeter of 214? Well, I have 107 here. When I take that times 2, I get my 214, so it does check out. Then number 7, the length of one side of a triangle. Notice that we have it in italics here. Make sure you know what you're talking about before you dive into solving this problem. The length of one side of a triangle is 4 inches less than the second side. The third side is 17. If the perimeter of the triangle is 41, find the dimensions of the first two sides. The length of one side is 4. It's not just 4. It doesn't say the length of one side is 4. What does it say? It's 4 less than the second. The third side is 17. The perimeter of the triangle is 41. Find the dimensions of the first two sides. Well, you know what? It usually helps if we drew a diagram. Draw a picture. And let's label it the first side, the second side, and the third side. Well, it says the length of one side, that's the first side. The first side is 4 inches less than the second. The third side is the third side is 17. So let's just put a 17. Label that third side 17. Now, the length of one side of the triangle is 4 inches less than the second. And look at what it says. It says to find the dimensions of the first two sides. So there are the things that we're looking for. We're looking for the length of one side and the length of the second side. Oh, which one's mentioned second? Yes, the second side. So let's call the second side, I don't know, let's call it S, since we're talking about the word second, starts with an S. So let's call the second side S. Now I need an algebraic expression for the one side, the first side. And what does it say about the first side? Well, it says the first side is 4 inches less than the second side. How can I write an algebraic expression that means 4 inches less than the second side? And I know that I'm calling the, what are we calling the second side again? S. So the first side would be what? 4 inches less than that would be S minus 4. Now here, because it's a triangle, I add up all three sides. So in other words, isn't it safe to say that we're going to take the first side plus the second side plus the third side, and that's our perimeter? So what are we calling the first side? Well, we got S minus 4 over there. Plus, what are we calling the second side? Well, it's just S. And the third side, what do we have for it? Well, it's 17. And that's all going to equal what? 41. S plus S is 2S. Negative 4 plus 17 is 13 is equal to 41. Subtracting the 13 from both sides, 2S is equal to 28. And S must be equal to 14. So what does that mean? What did we say S stood for? The second side. So our second side is 14. What's the first side? Well, it's 14 minus 4 is 10. Obviously, the third side was 17. Do those give me a perimeter of 41? When I add it all up, it does. It checks out. And that's how you do story problems pertaining to perimeter. We'll be doing more in class dealing with money and, well, just a lot of other things. So we'll talk about those later. Good luck in figuring out your homework problems, and I will see you in class.